Here we're asked which of these are like terms. So we're given 4 terms. And we need to identify which of these are alike. If they're like terms, they need to have the same combination of variables and exponents. So let's take a look. Now we're looking for ones that have the same variables and exponents. We don't care about the coefficient, the number in front of the variables and exponents. So if I look at each of these, I notice they all have the same variables. They all have x, y, z. But do you notice that the exponents are different? Which ones have the same variables and exponents? Notice that the first and last term here both have an x squared, y to the 4th, z to the 5th. So these have the same variables and exponent combination. So these two are like terms. And if I was given an expression or an equation, I can combine them and say, how many x squares, y to the 4th, z to the 5th do I have? Well, I have 4 here. And what's the coefficient for that last one? I see a negative sign, but not a number. If there's not a number, we assume that that coefficient is 1. So this would be not negative, it'd be -1. So if I have 4 and -1, x squared, y 4th, z to the 5th, then I take that 4 minus 1, and I see that I have a total of 3 x squares, y to the 4th, z to the 5th. How about the other two? Are these like terms? Yes, they both have x squared, y to the 4th, z. So these are like terms as well. So if I were asked to combine them, I can say, well, I have -5 x squares, y to the 4th, z's, and I have 1/2. So -5 and 1/2 would be -4.5 or -4.5 x squares, y to the 4th, z's. Let's look at a couple expressions. Here it says simplify the expression. So when you're simplifying an expression, if there's any parentheses, you first want to distribute before you combine like terms. We can tell this is an expression because the terms are separated by plus or minus signs. So here we have 5 different terms. So let's see if any of them are like terms that we can combine. I notice some m's, I notice some p's, but like terms have the same combination of variables and exponents. So if we look at the first one, we see that the variables and exponents are m squared p. Are there any other terms that have an m squared p? Yes, the last one. So these two are like terms. Notice for the one on the right, I also underlined that plus sign because it's important to know that this is a positive 8 m squared p. And over here on the left, this is also a positive 5 m squared p. So how many m squared p's do we have? Well, we had positive 5 and we added 8 more, so we have positive 13. Are there any other like terms? Notice here we have an m squared, and this is an m squared as well. So we have 2 other like terms that we can combine. So how many m squares do we have? Well, we had -4 m squares, and then we added 7 m squares. So -4 plus 7 is positive 3 m squares. And then here we just have a constant, no other numbers that don't have any variables or exponents. So I'm just going to leave that as plus 5. Along that lines though, what if I added this plus 2 at the end? Are positive 5 and positive 2 like terms? Yes, because they're just regular numbers. They're constants. We can always add 5 and 2. That's something you learned in elementary school. So you just add those numbers. So positive 5 and positive 2 combined is positive 7. Let's try one more. Now this one has some fractions, and if you struggle with fractions and you would rather use decimals, you can take each of those fractions and convert it to a decimal. For example, this is 3 divided by 4. If I put that in my calculator, I get 0.75. And then this is 1 divided by 2. If I put that in my calculator, I get 0.5. So you can also combine like terms for this expression. And if you have answers to choose from and it's a multiple choice question and you converted yours to decimals, then you can just go through each of the choices that you're given and convert those fractions to decimals to see which one matches your answer. I'm going to leave it as fractions. So if I look at this, which of these terms are like terms? Again, notice the terms are separated by your plus or minus signs. So we have 5 terms that we are looking to see if we can combine any of them. If you just start with the first one, this one has an MP. Are there any others that have an MP with no exponents? Yes, right here. So these are like terms. So how many MPs do I have? Well, I had 7, and this is minus 1/2. 7 minus 1/2 is 6.5. So I have 6.5 MPs. Now let's look at the next one. M squared. Are there any other M squares? No. So I can't combine this with anything, so that just stays as 3/4 M squared. P squared. Are there any others that have a P squared? No. So this just stays as positive 5P squared. Nothing can be combined with it. And then lastly, minus 7. There's no other constants to combine with, so I'm just going to leave that minus 7 at the end.